and by applying the analysis of variance for two-way classification, we find the ANOVA table here by finding total sum of a square as we calculated for CRD, sum of squares due to treatments, sum of square due to treatments, say row, sum of square due to rows, sum of square due to columns, or you can sum of square due to from blocks, that is column wise, and SSE, sum of square due to errors. And then we find the value of F by comparing mean or sum of squares due to treatments with SSE and SSB with SSE for blocks, and we find our result whether we reject our hypothesis, null hypothesis, or reject the null hypothesis. Similarly, we go for latent square designs. Where we find V cross V only number. For example, there are 16, so we take 4 cross 4 blocks, and by applying the principle of randomization, replication, and local control, we find the results of latent square designs also. Now I take an example of first CRD. Where we can apply CRD. For example, the following table example of CRD. Following table shows the yields in quintals per acre of a certain variety of wheat grown in a particular type of soil treated with 3 chemicals, say A, B and C. A, B and C. We get the following observations. A, B, C, 48, 49, 50, 49, 47, 49, 48, say 48, 49, 51, 50 and 50. Now, following table shows the yields. These are the yields in quintals per acre of a certain variety of wheat grown in a particular type of soil treated with 3 chemicals, A, B and C. Chemicals may be fertilizers. There are 3 fertilizers, for example, and we apply fertilizer A in these 4 plots. Here 4 plots here. We apply fertilizer B, say in another 4 plots. And we apply third fertilizer in another 4 plots. So total number of plots are here 12. Total number of plots. As theoretically here R1 is 4, here R2 is 4, here R3 is 4. So total number of plots are here 12, and for the variety of, to know the effect of fertilizers on variety, on a particular variety of wheat, we get following observations. And now finding the value of total sum of squares, total sum of squares due to treatments, that is fertilizers, sum of square due to error, and then we find the value of f by MST over MSE. And if we take null hypothesis that the effect of these three fertilizer is same, and after getting the calculated value of f at given level of significance, suppose we want to test it at 5% level of significance or 1% level of significance, we compare this tabulated value and calculated value with the tabulated value, and on the basis of, if calculated value is less than tabulated value, we accept the hypothesis, otherwise we reject the hypothesis as in our literature. So this is the example where here the number of plots are same for fertilizer A, for fertilizer B, and for fertilizer C. We apply fertilizers for same number of plots for a particular type variety of wheat. Now we take another example where the number of plots may be different for our treatments. Let me take another example. Another example, following table shows the lifetimes in hours of following table shows the lifetimes in hours of samples from three different types of television tubes manufactured by a company. For example, we note down sample 1, sample 2, sample 3. There are 3 samples, and here it is 407, 411 hours and 409 hours. And for second sample, we take values 404 hours, 406, 408, 405, 402, say. And for third, it is 410, 408, 406 and 408. Or if we like this, we write this form. Now if we compare this example with previous example, there are 3 fertilizers and here are also 3 samples, sample 1, sample 2, sample 3. But here R1 is 3, R1 is 3, and here R2 is 5, 1, 2, 3, 4, 5, and R3 is here 4. So this is the case when number of plots is different for different type of treatments. For here for sample 1 R1 is 3, and for sample 2 is R2 is 5, R3 is 4, and the total plot you can say here it is 4 or 5, 9, and 3, 12. So here in CRD it is freedom that R1, R2 and R3 may be different. So this is the one of the advantage of completely randomized design. Now if we consider an example of RBD, take another example of RBD. Like previous example, if we apply 3 chemicals ABC, and 3 type of say crop, 1, crop 2, example of RBD, randomized block design, say crop 3rd and crop 4. This is 4 cross 4, sorry 3 cross 4. V is 4 and there are 4 blocks, and if we note down the values, say example it is 3.5, 5.4, 7.6.3, 6.8 say, and it is, for example, that it is 5.8, 5.8, 5.7, and say 5.3. Similarly, if you take it is 6.8, 6.3, 6.4, and say 4.4. And by applying two-way analysis of variance for RBD, we can find the value of total sum of squares. Here number of rows are 3, number of rows 3, number of columns 4, number of columns 4. So like CRD, we find sum of squares due to treatments or row, sum of square due to blocks say or column, and sum of square due to error. And by putting the values in your ANOVA table, we test the hypothesis whether the effect from 3 fertilizers is same or not. So this is the example of RBD. Similar type of examples we can take Latin square designs. So but due to the time limitation I cannot take that. So this is the way how we apply CRD and RBD in different type of fields. So if is there any question, then we try to answer. No? Thank you.